All right, looks like there's still a couple of people rolling in. We'll give it just another 2 more minutes and then we'll start. All right, we're just rounding up the last of the people, so I'll go ahead and start the introductions here. All right, my name is Austin Jans, and I'll be leading the tutorial for the Advanced Networking 1 class. All right, and just a little bit about me. I am a graduate from the 2020 class for the Networking and IT Security. I came over to the university after doing the Durham College Bridge program for the Computer Systems Technician. So while I was in that program, I was doing a couple of classes over at Ontario Tech U. And then once I graduated, I came over direct into the third year. Uh, Over the past couple of years, I've been an intern for KPMG Canada under their collaboration and knowledge team, working with different internet technologies, so like SharePoint, a whole bunch of migrations, and mostly using PowerShell. But I enjoy learning and analyzing systems and algorithms, and one of my favorite pastimes is checking out the latest movie at the movie theaters. All right, and where you can find me. So you can find me at my Ontario Tech U email, and there you can either email me or use the Google Chat, and I will be hosting. Depending on interest, I can have a stream around lunchtime on Wednesdays, and then I was looking to get some feedback on whether or not Tuesdays or Thursdays would work better. So I have a straw poll here. If you guys would like to type in the link and just let me know which day works better. And I can post these slides. Oh, thank you for posting the link. The tutorial shouldn't the content shouldn't take the whole time, or it won't, but I'm gonna have a Q&A open at the end, so if you'd like to stick around and ask some questions, then I'll be available for that time. All right, and I'll let that straw poll stay open, and then we'll just continue here. All right, so for today's tutorial, we're going to go through some addressing review, so subnetting, VLSM, summarization, access control lists, and then we'll talk about the take-home lab, and then we'll finish off with some QA. All right. And addressing. So right now we'll discuss the IPv4 addressing, but just as review, addresses allow us to identify a network or a network device, and it helps give us structure to the network. And its specifications are 32 bits separated by into 4 octets. And this allocation is balanced between how many networks you need and your host identifier. And this is how the bits are broken up. So they are ordered in big endian. So they start off with the greatest value and work down towards the lowest value here. So say if in this example, we are converting 1011, 0101. So if we were to imagine that there was another row below, we would have 1 meaning true for the 128, and for the 32, the 16, the 4, and the 1. So it's and yes, these slides will be posted, but so this is just a basic conversion from 10110101 to 181. All right, and now going in the reverse decimal conversion to binary. So the way that I do it is I take we know that for most of our binary to decimal, it's going to be bounded by 255. So that means our top, the most amount of bits that we'll need is 7 bits. So if we check whether or not, so we'll convert 66. So we'll check if 66 is greater than or equal to 128, or our top value. And it's not, so it'll be false. False. Same with 66. It's going to be greater than 64. So it's true, so we'll subtract the 64. And then since 2 isn't bigger than 32, or 16, or 8, or 4, these are all false. And then 2 is greater than or equal to 2, so that's true. Subtract 2, and then we still have to check 1, which is 2 to the 0, and that's false. So if we take a look at this, false, true, false, 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 true, false, means that 66 base 10 is equivalent to 0, 1, 0, 0, 0, 0, 0, 1, 0 base 2. So this is the method that I found was pretty useful. We know that 128 is our top value, and you can pretty quickly go through 128, 64, 32, and just build this each time. And it's important to break them up into octets like this, where it's where you still include that leading 0, because it's important to know that that space is still taken up. All right. And moving forwards. All right, and reviewing subnets. Just like everything, subnets are balanced. They have to be balanced, and how you shift that balance is really dependent on one of the two main metrics, networks and hosts. So for example, if we look at a common network mask of 24, that means 24 bits are allocated for the network and 8 bits uh, are allocated for the hosts. And just like the network mask would show, there's 2 to the 24 networks. That's because there's 32 total bits, 24 allocated to the networks, and each bit can have 2 values, so it's 2 to the 24. And then for usable hosts, we have 2 to the 8 because there's 8 bits for the hosts, and we're subtracting 2. Can someone tell me why we're subtracting 2 networks? Yep, exactly. Bryce just answered it. One of our networks one of our addresses is going to be the network address, which can't be allocated to any host, of course, and the broadcast address. And once again, that one can't be allocated to any host because it needs to be used to send broadcast messages to reach the rest of the network. And then here's just a quick, just a little schema here following our X and Y. So we see that this portion is all taken up by the network. And the maximum value here for each of these octets is 255. And that's just because each octet counts up to 2 to the 7, and the maximum value for that is 255. All right, and we're gonna demo some VLSM, so variable length subnet mask. And that means that we're gonna take this 24 bit network, and we're gonna break it down into 3 of these subnetworks. So we need 100 hosts, 20 hosts for B, and 70 hosts for C. And what order are we gonna sort the allocation in? Are we gonna just go A, B, C, or are we gonna do them in any particular order? Yep. So it is going to be ACB. And the reason for that, just like Dennis said, is largest to smallest. And we want to go largest to smallest because we want to make sure that we have enough space for the next biggest network. So if we did 100 and then we did 20, it might be hard to make smaller networks later and larger networks. And we'll see what that means once we go through this demo here. So 192.168.0.0 is going to be our first network. We need to figure out, though, what our mask needs to be. So 100 hosts is how many bits should we need for this? So remember, our formula was 2 to the 8. Not 2 to the 8. So we're trying to figure out how many bits we need, and then we have to account that we're going to lose 2. So we can either use all 7 bits and create 255, right? So we can either use the first bit. So if we break it down, it's 192.168.0.1. So if we take 1 bit for the network, it'll leave us 6 bits for the host. If we take 2 bits for the network, it'll leave us 5 6 bits for the host. So we need 7 bits because 2 to the 6 is only 64, right? So we need 2 to the 7 because we need to accommodate for 100. So we'll steal this 1 bit. So right now, the /24 is and then it's and then this is the host currently. So we're gonna steal 1 bit and we're gonna make a /25. All right, so we've stolen this one. So now we need to figure out how many hosts that makes. So once again, we have now we have 7 bits to make hosts from, which is 127. But remember, we need to remove some. We need to remove the 2, which are the network address and the broadcast address. VLSM is a variable length subnet mask. So we're taking this top level 24 address and we're breaking it down. So say if because IP addresses as is becoming more and more apparent these days is they run out, right? So if we just give out 24 /24 addresses, we can only make 255 networks in this range. However, if we can take this 24 and we can make these 3 networks and not touch any other /24 addresses. All right, so this is our first address. First network. It's a /25. So the first usable. Can anyone tell me what the first usable address is in this network here? This is the very first network that we've built. 192.168.0.0/25. And yep, it is a /1 here. A .1. And our last usable address, and there it is, 127, and 127 is the broadcast. So the last usable would be 126. There we go. And then so our total usable is 126 actually. Yes. And the reason for that, it's 2 to the power of 6, to the 7 minus 2, which is 128 minus 2. Sorry, I wrote 127 earlier. All right, and let's give us a little bit more space. Can everyone still, yes, 126 usable. Can everyone still see the, okay, thank you. All right, and we'll move on to the next network. Here, I'll increase the size a little bit again. All right, and moving on. So now our new network is, so the next network has to start, we're going to start it right after right after this one ends, basically. So our next network is going to be the last one's broadcast plus 1. So we're going to have 128. So remember, the broadcast was 192.168.0.127 broadcast. Well, 0 network. All right. All right, and the next one, we need 70 hosts. So we will reorder this. And we'll go here. All right, so 70 hosts. And once again, this is going to be more than 64. So we're going to have to use a /25 network. And like we discussed before, that's because say if we had a /26 network, that would only give us 6 bits. And 6 bits can only give us a maximum of 62 usable addresses. So we will give this one /25. And like before, that's going to be 126 usable addresses. And can someone give me the start address? Yep, 129. And the last one, and like before, 254 is actually actually, sorry, yeah, you can use the 254 here, because the 255 would be the broadcast. All right, and last but not least, how many bits do we need for the 20 hosts? So if we think about it, 2 to the power of 4 is 16. Oh, whoops. Thank you. Yep, so 9. Yep, so it is 5. So we need to allocate these 5 bits. So then we're going to allocate 2 more bits to so the reason why it ended up being 254 is the 255 is the broadcast, and we allocated 7 bits. So that means we have 126 usable addresses. So 129 to 254 is, yeah. So that's so that goes right to the end of so remember how we only took one bit? 1 bit means that we have two networks. It means there's two networks that we can make that are /255 out of this 254. I mean, out of this /24. So this is actually a bit of a trick question because uh, you can only split a /24 into two 25 subnet mask networks. So this one, we can't actually make it. So one thing that you could try doing if you were like a company in this situation is try to limit these networks. So just like before, the amount of networks that we have is limited by the amount of users that we need in each network. So if we can bring this network down to 62 per se, you can make this a /26 because the /26 has 62 usable hosts, right? Because 2 to the 6 equals 64, and then we lose 2 to the network and the broadcast. And then if we can limit it by 8 users, we can build another network to handle 20 more. So if we go back and correct this, 129, and then we can handle 62 on top of that. Can anyone give me our last address if we have a /62? I mean 26. And remember, we are our first address is still this point 0.129, so we have to use that as our beginning. Yep, and there it is. So our last one is 190, and 128 is our network, and 191 is our broadcast. And 192 would be the next the network of the next network. And I kind of just gave away the answer to the first address in our I mean the network address of our next network, which is 192.168.0.192. And we already answered it earlier. So we actually switched, I was talking about it earlier, but we actually switched the 70 down to 62 because I was discussing how a /24 can only split into two /25 networks. And because both of these were /25, we wouldn't be able to make this this network be here. So I was discussing about how if you limit it by 8 users, you can bring it down to that next threshold and make that network be. All right, and we answered it earlier already, but we need 5 bits in order to make this one work. So we need a /27. All right, and our first usable is 193. And can someone give me the last usable? Perfect. So remember, there's 30 usable addresses, and that's from so we'd actually end up at 212. I mean, 222. Because there's 30 30 hosts. And then 223. Yep. So 223 would be the broadcast. And then 224 would actually be the network address if you had another slash 27 after it. So we'll just make note here. 192 is for the network, and 223 is for the broadcast. And I'll just make it a note here. And I'll just say here that slash 24 can only provide max 2/25 networks. So after you find so when you say what's the step after finding the usable host, do you mean the first usable host? All right. So in general, we'll make a new. All right. So to find the first usable host, it's the first address after the network address. So when we're doing that exercise there, our very first step was calculating the network address. So for VLSM, the first network address is the network that we're subdividing. And you don't really know the network addresses for the rest of the networks until you calculate all of VLSM. So here we only know that this network address is 128 because the previous network needed to extend all the way to .127. So once you're here, if we know that this is a slash 25 or slash 24 for that matter, we know that the first we know that the first 24 bits are going to be used. And right now, all of the rest of the bits are allocated for the rest of the bits are allocated for hosts. All right, so then the very first host just flips the first bit. So then it's a 0.1, and then 0.2, and then all the way until all of these bits are flipped. So it'll go 1, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1, and so on and so forth. So the basically the first host is just each host is just flipping more bits until the edge of the subnet. For the sorry, 1 second. I will start currently. It's not recording, but since it seems like you guys would quite like it, I'm going to make sure to record, and then I will make sure they are posted and available. So let me just take a second here, and I'll start the recording process. All right, it is recording now. Sorry, I from here forwards, the rest will be recorded. I was hoping to have the meeting actually on YouTube, which does the recording for me. But yep. So from now on, I will be sure to have a double recording, and then I'll be able to post it. All right. So where were we? All right. So when we're figuring out which are the usable hosts, we're basically flipping all the bits that are available to us in the slash in our subnet. So say if we switch to a /25, then we can only flip these bits here. And that's why we only have 30 usable hosts. So if we know that a /25 gives us 32 binary possible values, and then we know that the first one, the first address is going to be our network, and the very last address, where the very last address is our broadcast. Then we know that basically the last address is basically going to have this last bit. The last usable is not activated. So that means the last address is universally just the usable all the bits. So even say if we had a slash 30, meaning we have 2 usable bits left, the broadcast is going to have both of them turned on, and the network is going to have both of them turned off. And then the usable can either be 1, 0 or 0, 1. 1, 0. All right, so that's how we find our usable addresses. Basically, we're just taking the binary allocation for hosts and all the potential possibilities. All right, and is there any more questions in terms of figuring out how many hosts and how many networks we have? All right, we'll move on. So up next, we're going to talk about summarization. So route summarization allows us to summarize our routes in such a way that we only need to send one summary for all the routes in the network, in the different network structures. So for example, if we're setting up a summary for this, rather than sending 4 different updates, we can send one update. There's a question: in a private network, could the subnet theoretically be any kind of address a person wanted? Technically, you could set it up like that. However, it would potentially break the network, because that address, if you select a public address, your router is going to want to, it's going to try it's not going to translate that address. It'll know that it's local. However, if traffic is actually trying to get to that destination, it won't make it there, because it has a private source for that, for a host that has that IP, so it wouldn't reach out to the internet. So it's like, because the way that it works is, when you make a request, it goes through DNS and returns the IP address. But if there's an IP address that's already in your network that matches that, it's just going to reallocate to that. So if you make a valid request to that IP, it could fail. So you want to use private addresses. So something like a 192 address, or 10, or a 10 address. But yeah, as long as there's no internet connectivity, yeah, you can really give whatever address you'd like. All right, so let's create a summary for this route. So the route summarization, you want to take a full list of the networks you want to summarize and then see what bits they have in common. So here they're all /24, so that so we know that the max, we know that they're allocating these last 8 bits for hosts. All right, so we'll start from left to right. The first octet, they're all the same. The second octet, they're all the same, and we can tell that by the octets here. They're all 172.16s. And the homework labs are, this is just the, I believe there's just going to be homework for this first week, the lab 0, and then the rest of the labs, I believe they're going to be using, I believe it's virtualized equipment. However, this is the only like written homework that I'm aware of for the tutorial. And the homework lab for this week is due on the 28th. All right, and so then it's this third octet where we see they start changing. So we have this bit activated on all of them, and the next bit activated. However, it's these last 2 bits where we see the change. So that means we can separate them right down here, and that's where we could summarize. Like, we could tell other devices on the connected networks that we have just a single summary address rather than saying we have 4 different networks. Which makes sense because we take 2 new bits. Between these 2 bits, we see all 4 combinations. We see 0, 0, 0, 1, 1, 0, and 1, 1. So then the solution is 172.16.12, and then dot 0, and that's a /22 network, because now we're only taking 22 of the bits and we're allocating 2 of the bits as the summary. So once again, we take all of our networks, we line them up, we write it down in binary form, and see where's the last place all of the bits lined up. So here is the first 22 bits, and then we allow 2 bits for the summarization, and that works out because we have 4 networks, and the 2 bits allow for the 4 networks. All right. And moving on to our next topic, we have access control lists. Access control lists are kind of like our very base level firewalls. However, they are limited. You'll see later that we can use different technologies like route maps to really fine tune how the traffic is passed through the devices. But access lists are a way of us creating rules for permission and denial, and we can use ports so that it matches up with different services that we're using. So they provide basic security, and the recommended configuration is that standard access lists are applied to closest to the destination of the traffic, and extended should be as far as possible from the traffic, which the name is kind of intuitive, where extended is kind of like it's furthest away from the destination, putting it closer to the source. So usually when we're thinking about how traffic flows, or at least the way I think about it, I think about how the traffic arrives at the destination. So if you think about it, standard access control lists are the ones where you don't have a lot of control over the entire network. That's why you put them close to the destination, because that's the portion of the network that you have the most control of. Whereas extended allows you to extend further and further closer to the closer and closer to the source to prohibit the traffic as soon as possible, rather than having it get all the way across the network, getting it really close to the destination only to be denied. So the extended ones, being close to the source, limit how much traffic can get across the entire network before being denied any further passage. So that's the basic level of access control lists. You'll have a chance to use them in your labs, but basically, yeah, it's a set of rules that either permit or deny traffic. All right, and we'll take a quick look at the homework that is posted, and then we'll do a Q&A session, and I'll provide any extra demos if you have any questions. As for its total percent mark, I'm not 100% sure how much it is. It may actually be, in fact, be worth the same as just a standard lab, but it's just a pretty simple refresher of how to use the VLSM tactics that we're just talking about. So I'll go ahead and I'll walk through the homework, and then we can do some Q&A. All right. All right, can everyone see the document? All right, perfect. All right, so your main task here is just creating the VLSM scheme for this network. So here's the diagram, and we have our different segments. So just like before, we'll get a listing of hosts and the hosts required, and then after that, you'll order them, break them down, find the first usable. So yeah, host IP allocation, prefix, usable range. So it's basically exactly what we went through during the tutorial. This tutorial, we have yet to go through a network that requires more hosts than the last octet. So if there's interest, I can go through what that looks like during our Q&A period. So yep, it's pretty simple. It's a great little it's almost like a puzzle where you have a main network and then you're just subdividing it to make this larger structure work. So we do want to see the work. We do want to see your work, but specifically for server farm 3. So this is our base subnet here. We've allocated the 192.168.0.0/16. All right.
Our
And
assignment from like that.
all right, and that is pretty much the end of the main tutorial content. Would someone like to see anything broken down? Maybe any more VLSM demos? All right. I see there is some requests to do 1500 hosts. Okay, cool. All right, and I'll switch back over to our presentation. All right, VLSM. We'll go. Let's switch it up a little bit. We'll do 1,337 hosts. It's going to end up being functionally the same as 1,500 hosts, but figured we'd shake things up a little bit. Exactly, yeah. All right, so let's have a network address of 42.42.00. So we'll go with another /16. So can someone give me how many bits we're gonna need for the 1,337 hosts? Yep, it's 11. So 11 is 2048. 2048 hosts. And then if we draw out our bit graph, well, not a bit graph, but our scheme here. All right, so we need 11 bits for the hosts. So there's our first 8, and then we need 3 more. So that means we can get by with giving 5 of our 32 bits back to the network. So that means now we can go in with a 42.42, and then the first 5 bits in order to get this network address. Yep, so we'll start right at 0 again, 0, and then /21. So we can do the subtract 2. 2048 is actually just 2 to the 11, and then we can subtract 2, which gives us 2044. And for us, that's going to be way more than enough for our 1337. So our first usable for this one would be 42, 42, and once again, 0.1. We're just flipping this bit here between a 0 and a 1. So we got 1 here. And then our last usable oh, yep, sorry. 2046. Our last usable, we can flip these bits as well. Not only these first 8, we can flip the first 3 of this third octet. So once again, 42, 42. And then the maximum value you can get from these 3 bits, you can have 7 different values. And well, technically it's 8 different values because zeros includes it's including 0. So we have 1, 2, 3, 4, 5, 6, 7. So we have 8 different values. So 2 to the 3. But because 0 is one of the values, our maximum is 7. And then our last one is 254. So our very last one would be 111. And then these would also be 1. And then remember, the last bit is reserved for our broadcast address, which is 255. So our network is and yep, sorry. So the 11 is, like your colleagues have said, is from the fact that we need 11 bits to make up 1337 hosts. We can't use 10 because that would only give us 1024 or 1022 usable. So we have no choice but to actually take one more bit and double the total amount of addresses that we have. So it's 7 in the third octet because we have 3 host bits in the third octet, and 3 host bits we can either have there's 8 different possibilities. Yep. So yeah, we have 7 total. So we have 8 values, being 1 to 7. And the way that we can calculate this when we need to in the future is we have 3 bits for the host in this octet. So that gives us 8 now 8 potential values. Yep. And yep, so I just so remember, this last bit is always going to be used for the broadcast. So if you ever want to find the last usable, you can make this schema here where we have our network addresses as the X's, and then ones fill all of the open positions except for the last one. All right, so that's us breaking down our 42.42/16 network into our r/21 network. And what's great about that is now, rather than using all of this network, we're actually using a relatively small portion. We're only really allocating 2048 addresses total, and 2046 usable, but a /16 network address allows for far too many hosts. A lot of it would be wasted. And yeah, so this document that I'm editing here is actually, I'm just going to post the edited document. So you'll be able to go back and see the various notes that we made during our tutorial today. I'm still recording, yes. All right, is there any more questions? And just to close off, I'll go back and just review our straw poll so that I know what times are most preferred. It looks like the Tuesday is going to be the day where I'll hold the office hours in the evening, 6 to 7. And then I'll still send out an announcement during those Wednesdays that I run, just a quick lunch a lunch hour, like a lunch, like half an hour, so that if anyone has any more pressing issues that come up after Tuesday, then I'll be there. All right, it looks like there's just one question that came in. Why is there 11 for the IP requirements for the example question in 0? All right, so it looks like so basically what they're saying here is that this is how many 11 is how many addresses are needed. So they allocate 14 because they're using 4 bits. So remember, 4 bits can give 16 addresses, and 2 of them aren't usable. So you'd have to allocate 14 addresses to supply 11. And sorry, this is attached to the lab 0 rather than our example here. So I'll go ahead and switch back over. Yes, and that last question that came in from Franklin, I borrowed 5 host bits because we didn't need them in order to make up our 1337 hosts. So we made a /21 just to save on space. All right, and just a quick question that came in was regarding the IPs required. So we allocated 14 because that's the next minimum. So that's 2 to the 4 bits. I mean, yeah, 2 to the 4 is 16, so we need 4 bits. Exactly, yeah. So we can only split a /24 into into 2 /25s, and I'll quickly go through why that is here. So basically, if you imagine, say if this is our first octet, this is our second octet, This is our third octet, and then we have a 0, right? So if you think about it, this can go from 0 to, this can be any of these bits can be turned on for this. And what we're saying with the /25 is that we're going to take this bit away from that to make networks. Now this bit here can only be a 0 or a 1. There's only 2 different possibilities for it. And because of that, you can only make 2 networks by taking 1 bit. So here, this is 1 network. And if you allocate that one to the network bits, you can make 2 networks now because this bit can be a 0 or a 1. And for the homework, it could be that I'm just looking at an older version, but it's likely for the same reason though. Why there's we always have to allocate to the next available. We always have to allocate more than we need. But this here is why. So it's because of this last bit here. All right, so I'll be sure to make these slides available and along with the video as well. But this going from a 24 to a 25, you can only make 2 25 networks out of a single 24. Is there any other questions? Is there any other demos that you guys would like to see? All right, I'm gonna call it there. If you guys have any questions that come up, I'll be around during tomorrow's lecture as well as the office times that we discussed, and I will make the update as well as an announcement whenever I can on Canvas as soon as I get access. So I will highlight Tuesday. All right, thank you very much for joining, and I'll see you guys next week. Thanks, guys. Sorry, the office hours, I will, those ones will be a link that I will have to post on a more weekly basis, just because of the virtual environment. I have to start a new stream with each office hours. But yeah, I'll make sure to post those at least 20, 25 minutes in advance. All right. And thanks, guys. Have a good day.